All right, good morning, everybody. So I'm going to talk, the title of my 10 talk is How a $1 part takes down a $1 million network. And hello. Clicker's not working, of course. Why would it? So I'm going to start off by talking about one of these little self-help books. This one came out about 25 years ago, 30 years ago, right? It's called Don't Sweat the Small Stuff. Talks about, how to live life kind of a little more calmly in an insane world, making peace with imperfections and all of that stuff. Don't let little problems take over your life. Fernie? For you.
Thank you.
Because in Wi-Fi, I'm throwing that book away. Always sweat the small stuff. All right? You can't tolerate imperfections, right? You got to plan your network for the future, right? Because your needs are always going to grow. And these little problems will take over your life. So, right, the small stuff that emerges at the start of the project, guess what? Requirements and constraints, CWNA, CWDP material, right? When we talk about requirements, we're talking about coverage. We're talking about usage. We're talking about capacity, and we're talking about constraints, right? Coverage is, where do I need the Wi-Fi? Usage, what's going to be on the network, right? What applications, what devices? Capacity, how many of these damn things are there going to be? And constraints, what are the things that I have to work around in the environment in order to make everything work? And the constraints are the ones that really tend to hit you up, and that's budget, aesthetics, where I can run wire, all of that kind of jazz. But the devil is in the details, right? We all worry about access points. We all worry about switches, routers, making sure all our VLANs are set up correctly, our IP scopes and DHCP scopes are all set up correctly. But the stuff that we tend to not worry about is the stuff that kills you on a project, right? Infrastructure cabling, terminations, patch cords, rack space, electrical power, mismatch configurations, and even reading the plans wrong, which I'll show you an example of. So I'm going to go through a series of examples. First one was a film studio. This was a $4 million project just on the Wi-Fi side. Like, we had actually more money within Comcast invested in this project, but just on the Wi-Fi side, it was a $4 million project. We had over 300 access points, over 150 switches. It was 8 studio buildings and then multiple support buildings. We had dual MPOs, each one with 100 gigabit fiber coming in. So I mean, this was intense. But you know where we got screwed up? Fiber terminations. We had one vendor doing the building-to-building connections, and then we had another vendor doing the intra-building connections, right, from the MDF to the IDF in each building. Well, one of them used LC-UPC, which is what we spec'd out. The other one used SC-APC. So I got everything connected within a building, but then I couldn't tie them together because I had 300 patch cords that just didn't work. Right? We also had mismatch configurations because it turns out that our router supplier absolutely recommended you got to have forward error correction on your fiber link. Yeah, unfortunately, the switch we were plugging into didn't even support fiber error correction. So we had to, that was a hard one to find, turn it off, everything was working. So sometimes you have to not follow the best practices of your vendor. Second example, baseball park. This was a $150,000 project, about 25 APs, 7 switches. Half of the APs were point-to-point links. Those are the lines that you see on the bottom. And it was 60 gigahertz point-to-point links. And we had a 2 gig fiber at one end. And I know it's hard to see without my pointer clicking, but you've got you have an upper point-to-point path and a lower point-to-point path, right? And that's how since they were 60 gigahertz links, they're each supporting a gig. Well, one small problem, where it says building A, I don't know if I can't highlight it, unfortunately. We had bad outdoor Ethernet patch cables. We just had a bad batch of outdoor patch cables. So we were getting 100 megabit half duplex on one of those core point-to-point links. So half the park was not getting the throughput that they needed, right? Just because of that bad patch cord. Right? We also wound up with mounting issues because of where our business partner put the mounts was not exactly where we had specified them to go. And then we wound up having to last minute replace everything with custom mounts in order to make the antennas and everything fit. Another one, fast food chain, thousands of multiple drive-through stores, right? They had an outdoor AP in the kiosk. So we had some, and they were using GameChanger cable. I've heard good and bad things about GameChanger cable. My own experience with GameChanger cable is that it works great if you know how to install it. And if you install it properly, it works great. But it's very easy to mess up. So we had improper terminations on the GameChanger cable. We didn't have proper grounding. They forgot to put the weather cable glands in for the Ethernet ports. And we would get condensation inside the box, which meant that the Ethernet ports were rusting. Right? Nobody's seen that before, I'm sure. There was no ventilation in the boxes, so we were actually cooking these APs. So let me ask, do you want fries with that? That looks like a pretty nice burger to me. Because that's what they were making. That's not what they were intending to make, but that's what they were making. Another one, outdoor amphitheater. $500,000 project, 30 APs, 100 switches, that's wrong. Over 10 switches. 10,000 seat amphitheater for concerts. Again, 60 gigahertz point-to-point links for interconnect locations. We had a problem where you could see the heat map on the bottom shows that like the back half of the amphitheater really wasn't getting very good coverage, even though we had APs all along that left side there. Turns out they misread the plans. What you can't see is that little aisle in the back is about 20 feet below the top seats of the amphitheater. And the support buildings back there for the check-in and the restrooms, we had the APs on top, but those APs were actually lower than the top riser for the seats, which meant that I was covering this little alleyway where people were walking, which I needed to provide coverage in, but I had nothing covering the back of the amphitheater. So I had to add 4 new APs and 2 additional point-to-multipoint backhaul links, right, in order to fill in those coverage gaps, right, simply because the plans were misread, and somehow when it got installed originally, nobody caught the fact that, this is actually 20 feet lower than we think it is based on the plans. So, conclusions and key takeaways. Over-communicate with your customers and your vendor partners, right? Get your requirements out of the way early. Make sure that if there are things like, hey, you're reading the plans wrong, right, that gets communicated when you survey. Make sure that you actually know what your vendors are going to put in terms of terminations. Don't assume what makes sense to you is going to make sense to everybody else, because we're all professionals. We all think this stuff every day, right? But sometimes, especially customers and even our business partners, right, they're not necessarily thinking about it the way that we think about it. Specify everything. Don't be afraid to over-specify your requirements. Now, sometimes they won't follow it anyway. Get eyes on site, especially for the more complex projects, right? You always see stuff. That amphitheater one, I finally got eyes on site after we were struggling with it. Within 5 minutes, I was like, that's 20 feet up in the air. It shouldn't be. I found it in 5 minutes. Did a whole survey to prove that it didn't work, but I saw the problem in 5 minutes, right? But I wouldn't have seen it without eyes on site. And then finally, don't be afraid to get your hands dirty. Don't be afraid to go out there. Don't be afraid to jump into equipment, right? Just go out there and do it. And hey, I got 10 seconds left. This is the first time I've ever not run above time. So thank you, everybody.